Good afternoon, everyone. My name is Malik Arslan Nisar, and I am a TA for this course, Numerical Linear Algebra. And today we are going to discuss some sample problems for whatever you have read in the week 5. So, anyone who wants to summarize what you did during the week?
Yeah, this week we have that floating point representation,
Yes.
then round of errors, then error propagation in computer arithmetic, then addition and multiplication of floating point numbers, and the
Yes.
conditioning and condition numbers. That's a part one this week we had.
Okay, yeah. Conditioning you will be reading more in the next upcoming
Yeah,
weeks,
yeah.
I guess.
This some introduction we have, and some questions are also there in assignment, conditioning.
Yeah. So, did you go through the assignment and
Yeah, yeah, we went through that. The float, that's addition and multiplication, and all. I have some doubts.
okay. I have some like I today will be solving the previous year assignment,
Okay,
and I think that will more or less be related to the like questions you have been given in this assignment.
okay,
So
okay.
I think that will clarify your doubts.
Yeah.
So let's get started. So is my screen visible?
Yeah, yeah. To some extent, some messages.
Okay. Okay. So I hope my screen is visible.
Yeah, yes.
Okay. Okay, so we'll not waste more time and so the first question is let epsilon x, epsilon y, comma epsilon denote the relative errors in the computation of x, comma y and x plus y respectively. If x and y have the same signs, then which of the following is correct? First option is epsilon is approximately equal to epsilon x minus epsilon y. Second is epsilon bar, it's bar here, can be neglected. And the third option is epsilon is less or equal to the summation of epsilon x plus epsilon y. So, do you want to give it a try before we discuss it? Am I audible? Hello?
Yes, yes, you are audible.
Uh-huh. So, you are trying this question?
Okay.
How will we approach this question?
This is a relate to errors are given. So
Yeah. What are you saying? I'm
yeah,
not.
relate to errors are given, ma'am. So I think
Okay.
that
Yeah.
third is correct.
Third is correct, right? So how
Yeah.
did you do it?
That EA epsilon x equal to x minus x approximated by x, like that we can do now.
Okay. See, I'll show you how we do it. It's like simple. We know that x star can be simply written as x into 1 plus epsilon x, the error associated with it,
Yeah.
right?
Mm.
And similarly, y star will be what? Y
Y
into
plus 1 plus
1 plus epsilon y.
yeah. Mm.
Now,
Then
for calculating the error associated with x plus y, we know that it will be of some form x plus y. Suppose it is z. We can simply say it is f of z, uh, and it can be written as, let me erase this. Uh, yeah. So it can be simply written as z into 1 plus epsilon, right?
yeah.
And where we know that z is equal to what? X plus
So,
y into some 1 plus epsilon. And if we individually calculate it, we know that it will be equal to x into 1 plus epsilon x from here, right? Plus y into 1 plus epsilon y, correct?
yeah.
So here what we can do, we can write it as x plus epsilon x into x, then y plus y into epsilon y. And here we can write x plus y into 1 plus epsilon. Here you can write x plus y, then plus x times epsilon x plus y times epsilon y. Then in the next step, since you want to make the expression on the like right hand side equivalent to comparable to that on the left hand side, what we will do, I will divide this x and y by x plus y, right? We can do that. We can simply write it as like x plus y, multiplying and dividing this by x plus y, it will give us x plus y into what? X upon x plus y into epsilon x, and plus y upon x plus y into epsilon y. Understood this step?
Yes. Um,
Now from here, this x plus y will go, this x plus y will go, and this x plus y will go. So what we
it's
get is 1 plus epsilon will be equal to what? X upon x plus y into epsilon x, and y upon x plus y into epsilon y. Correct?
yeah.
And wait a second. This plus y. I think I made a mistake somewhere. Did I do the steps correctly?
Okay.
X into, yeah. Wait a second, let me check this again. X plus y plus x times epsilon x plus y times epsilon y. Then dividing this. Okay, sorry. Here it will be 1. It will not be 1 plus. This step is not correct. When we are dividing this by x by y, let me redo it from here. Here we can simply multiply x plus y, then x plus y and 1 plus epsilon, and here it will be wait a second. Yeah, x plus y plus epsilon times x plus y, and here x plus y plus x times epsilon x plus y times epsilon y. Now this x will cancel this y will cancel this y. And now we will get epsilon of x plus y equal to x epsilon x plus y epsilon y. Understood till here?
Yeah.
Now we will divide this x plus y on the right side and we will get something like this. Y upon now. So what the question was asking us is that now the e plus ex is the error associated with x, and ey is the error associated with y, and now we have to compute we have to comment about the error associated if we add x plus y, right?
Yeah.
Now you can see that this expression, right, x upon x plus y, when given that x and y are of the same sign. So
Yeah.
when x and y both are of same sign, you know that x upon x plus y, what will be the value of this thing?
It's be less than.
It will be less than 1, correct? If both x and y are negative, they will add up to form a negative number, and
The magnitude will take.
the magnitude will be less than 1. So it will be same for this also, and it will be same for this also. So this thing is less than 1 and this thing is less than 1. Now anything multiplied with epsilon x which is less than 1 will turn it into something which is less than epsilon x. And similarly, if this number is less than 1 and we are multiplying it with epsilon y, it will give us a number which is less than epsilon y.
Yeah.
Correct?
Yeah.
Then this number is less than epsilon y, this number is less than epsilon x, and they both add. So means this epsilon, its magnitude will be less than the absolute magnitude of ex plus ey. Correct?
Yes.
So from this, the option number
3
is
is
correct. So moving on to the next question. Should I move ahead?
okay.
If you have copied this. Now let ex, comma ey and e, again the same values, denote the relative errors in the computation of x and y. Denote the relative errors in computation of x, y and x by y. Then epsilon is equal to epsilon x plus epsilon y. Epsilon is approximately equal to epsilon x minus epsilon y. Mod of epsilon is less or equal to epsilon x plus epsilon y. And fourth option is epsilon can be neglected. So give this question a try, then we will discuss it. So any clue how we will approach this question? Similarly as we did in the previous question, right?
Yes.
Yes, please try it on your own and tell me if you're getting the answer. What are you getting? Anyone who did this? See, again we will say let z is equal to x by y, right? And the error associated with it will be something like this. And we know that x can be written as x into 1 plus epsilon x, and y will be 1 plus epsilon y, right? From here, it can be written as x plus y in x by y into 1 plus epsilon x into 1 plus epsilon y to the power minus 1. Now, you can expand this series, right? 1
Say
plus.
y can be cancelled on both sides, right? That is possible.
No, the idea here is not to cancel, but yeah, we can
Okay.
do it that way also. But basically, I will just compare the terms. I will bring LH right hand side in the left hand side format so that it becomes easy.
Okay.
Like XY is on the right side as well and it's on the left side as well. So this term and this term can be compared, right?
Yes, yes,
If
yes.
I take one here and the rest another term here, then I can directly compare epsilon with epsilon x. I can do it that way also, cancelling like I did in the previous question. So here you can see now 1 plus epsilon y to the power minus 1, you can expand the series, right?
Yeah.
It can
One.
be written as 1 minus epsilon y plus epsilon y square minus epsilon y cube and so on, right?
Yeah.
And you know that in like computations, we neglect second order and higher order terms, right?
Yeah.
So these terms will vanish. We will not consider them. It will be 1 plus epsilon x into 1 minus epsilon y. And it will be further like 1 plus epsilon x minus epsilon y plus epsilon x into epsilon y. Again, this is a second order term, right? So
Yeah.
this will not be considered. So it will be something like x by y into 1 plus epsilon x minus epsilon y.
Actually, 1 plus epsilon x. Okay, okay, okay.
And okay.
Okay.
So now seeing from the left hand side, you can directly compare the values. So here you can see epsilon is equal to epsilon x minus epsilon y, correct? So option 1 will be, sorry, option 2 will be correct. Noted till here?
Yes.
So everyone understood this?
Yeah.
Okay. Then let's do a simple like problem on this. So consider the 4-digit decimal system with um, rounding the relative error in the numerical calculation of x equal to minus 5 pi plus 7e minus 3 by 17 is. So quickly find the, like, give this question a try. I hope you'll be able to solve it. Then we can discuss it as well. Calculated this? This is not that difficult. Tell me if any one of you calculated the answer. Anyone? Kavita, Gifty, are you trying
No.
this?
Yeah.
Just using the calculator, I get the answer 3.14353.
Yeah, but how do you calculate the
I
relative
don't
error?
know how to,
Okay, so you,
actually, I don't know how to do this question.
okay, but I think there might have been, because did you go through the week's lectures?
Yes, but this type of
Yes.
problems are.
Okay, so see, you have to do a relative. This kind of problems, didn't you find these in assignment? Because this is the previous year assignment, so I don't know how different the this year assignment is. Are there any sums like this in your assignment?
Yeah, finding rounding error and all is there, but stay. It's not there.
Okay, okay, fine. See, we have to find relative error, right? What the relative error is? The x minus x star upon x. This is the relative error, right? The actual value of x minus the, like, rounded of error, the rounded of value of x divided by the actual value of x. That is how we find it. Now tell me, as Kavita, you said that x, while you calculated this on calculator, that is the actual value. So you are getting it as 3.1433. 358943. Correct?
389.
Right? This is what you're getting now.
3.1435389.
Yeah, but 4 3 is also there because I calculated it on my end. So this will be the actual value of x. Now, if you're calculating x star, so tell me when you will round off this number, what will be the round off of this number? How we do that?
3.1436.
0.144.
3.144. Yeah,
Four
it will be
digit number system.
3.144 because it is a four
Four
digit
digit
decimal
number
system.
system.
So
4
t is equal to 4, right?
Yeah.
So
Okay.
basically what we do, we take this as 0.31435, whatever
Into
it is, so on, into 10 to the power 1. Correct?
yeah.
Then since t is 4, we check for the first 4 digits, and after that we see, look at this 5. This 5 is what?
Greater
We have to
than
see if it is greater than or equal to beta by
5.
2 or less than that, right?
Yeah.
Now beta is 10, so beta by 2 will be 5 itself. So this number is equal to 5, so rounded off, this will increase the value of 3 by 1. Correct? It will be
Yes.
0.3144 into 10 to the power 1. So x star will be 3.144. Correct?
Yeah.
Now there is nothing left. Simply you have to put this in this expression, 3.143588943 minus 3.144 divided by the actual value. Now do it on calculator and tell me what you are getting.
One point 306 e power minus 4.
No, I think that is wrong. When you calculate it, it will be something like 1466 8 and so on into 10 to the
Into
power minus
minus
4.
4. Yeah.
Now since this is a 4 digit, we will again round it off to 4 digits.
Yeah.
That is, again we will do something like this. Now here this 1 2 3 4, so this digit we have to change. Since this 8 is greater than beta by 2, so
This
again the
is
value,
0.14666 at e power minus 3 will come. No?
huh?
It's, 0. If you write it 0.1466, then it will be 10 power minus 3. Isn't it?
Yeah, it will be here 10 to the power 1, then into 10 to the power
Yeah.
4. Okay. Because at last we multiply this, na? That's why I didn't do anything with that. Yeah, it will be something like this. And sorry, this is t to the power 4, so we have to round off the fourth digit, right?
Yeah.
So the fourth digit is 6 and it will change to 7. So the correct answer will be 1.467 into 10 to the power minus 1. This is how you do it. Correct? Understood this question, or there is
Yes.
any doubt, or do I need to explain anything again?
Just saying one more problem in the same type.
You want another problem, like similar problem?
Yes.
Yeah, we
Yes.
will do by the end of the session, we will have done enough problems that you will understand this concept. Okay, like you'll be able to do
Okay.
yourself also. So
Okay.
now moving further, consider this question. Consider the 4-digit decimal system with rounding, then the relative error in the numerical calculation of x equal to 13 by 15 minus 7 by 9 whole divided by 2 pi minus 2.4 is. Yeah. Try this question on your own and tell me what you are getting. Please take care of these like 4-digit decimal system or what, like this will help you to understand up to how many digits you have to round off. So that is important. Tell me when you're done. Because like there is not much to understand in this week's lectures because it's just calculation. So the more you practice, the more you will get the hands on of doing it. So I'll wait for you. You can attempt it.
It's 4.056 into 10 power minus 4.
No, I don't think that is the correct answer. Kavita and Amal, did you get the answer?
That x is 0.02289, something like that.
X is what?
X equal to the full x. 13 by 50 minus 7 by 9, that is 0.0228 and something like that. So
0.022, yeah. That is correct. After that, what is X star?
then x star is 0.0229.
229.
Yeah.
No, that will not be 229. There you have to check.
0.023.
0.023. What is that? The final answer?
X star. No, X star.
0 point?
Sorry, 023. Rounded.
No, T is
rounding
4
value
here.
of x.
T is 4. So you have to take up to 4 decimal.
So 0.2289.
Yeah, 0.02289, correct?
Into 10 power 1.
Then after that, Rx will be x minus x star upon x, right? Then why
Yeah.
are you getting error in that? You have done it correctly till this point. Check that once again. See, again, for calculating the absolute value, we know that x is what? 13 by 15 minus 7 by 9 upon 2 pi minus 2.4. You can simply enter this value into the calculator, or you can do like 13 into 9 minus 7 into 15 upon 15 into 9 whole divided by 2 pi minus 2.4. So 13 into 9 is what? It will be 117 minus 7 into 15 is 105 upon 15 into 9 is what? 135. This will be 12 by 135 whole divided by 2 pi minus 2.4. Now this you can simply do in calculator, right? And
3.83.
yeah, the value of x which you are getting is 0.02289071519. This is the value what you're getting. Now for x star, what we do, we first calculate, I'll write it again, 13 by 15 minus 7 by 9, then 2 pi minus 2.4. What is the value of 13 by 15? Do it fast. 13 by 15.
0.8666.
0.866. Can I put a bar on it?
Yeah.
Let me write one more digit. 0.86666 and so on. What is the value of 7 by 9?
0.777 bar.
0.7777
Bar.
bar, right?
Yeah.
And similarly, 2 pi will be what? 6.28318.
Yeah.
What is the value of 2 pi?
2.4.
One second. 185307 and minus 2.4. Correct?
Yeah.
Now here, since here again, I'll remind you, it's t equal to 4. So up to 4 decimal places we have to round off. Now look here, it's 8, 6, 6 and 6. So this last, the fourth digit, that is the third 6, we have to round this off. So this 6 will become what?
7.
7. Why? Because again, the
Rounding.
next digit to it is greater than beta by 2. So we will increase a 1 here. So it will be 0.8667. Similarly here, it will be 0.7778.
8.
Correct?
Yeah.
Now in denominator, when you round off this, it will be what? 6.283.
6283.
Why? Because after 3 there is 1.
1 is less than t.
1 is less than beta by 2, and that is why it will be equal to 6.283 and minus 2.4. Now this you are getting as 0.0228946. Are you getting the same?
Yes. Actually, is it possible to round x itself? That's
Sorry?
correct. Earlier we computed x, no, in calculators. But before that, first we computed x at some value, no?
Uh-huh.
Can we round off that
Okay,
instead of
rounding off that.
yeah?
No, basically, see, the
Otherwise, we
upper,
will be each element we have to round off and do.
yeah, because yeah, this is the standard way of doing it because
Okay.
see, if there are functions,
Yeah.
then you have to round off at each step,
Okay.
correct?
Okay.
So now, since this value, now you round off this one. So up to 4 decimal places, what will be it? It
Zero
will be
point
0.02289,
two nine.
correct?
Yeah.
Now here you can ask that 8 is the last digit, right? 8 is the fourth digit. Then why did you take 9 as well,
It should
right?
be written in 0.22289 into 10 power minus 1. Then only we have to round off.
Yeah, because when there is a 0 here, you don't round off that.
Yeah.
D1 should be 1. So what you do here is that you put it as 0.2289
2
into 10 to the power
minus 1.
minus 1. Then you see what is the fourth digit. The fourth digit is 9. So again, it will not change because after that you
4
have
is
4 and 4 is less than beta by 2. Beta is again 10, beta by 2 is 5 and this number is less than 5. So this will remain unchanged. It will remain 9 only. So that is why you put it as 0.02289. Is this understandable?
yeah.
Okay. So now this is the value you're getting from here. Now again Rx is simply nothing but you will do x minus x star divided by x. You're taking modulus here and this will be
3 1.
0.02289711519 minus 0.02289 whole divided by the actual value.
0.028 times 7151.
So it is 3.124 into 10 to the power
Minus.
minus 5. Fine.
Yeah.
Understood, Kavita? And
Yes, ma'am. But doing problem, I made a mistake.
huh?
It is understandable, but while do the problems, I
Yeah,
made a
yeah.
mistake. Not getting the
There
right
are some,
answer.
yeah. These problems are
Easy,
simple because the week's content wasn't
but
that heavy, but you can make errors while doing it. So do it carefully while you're doing it on
mm,
calculator. Okay. So next question is okay. So for what value of x the function f of x is equal to e to the power x upon x is well conditioned. So, can you try this question? For what value of x the function f of x equal to e to the power x upon x is well conditioned? And tell me the answer you're getting. So how will we do it?
We have to find the condition number, that is x into f dash of x by f of x.
Yeah,
Then we
correct.
have to find.
So can anyone tell what conditioning is, what a condition number is, since we are doing a question on that topic?
Actually, it is a measure of how well behaved a computation is.
Yeah.
Suppose if a,
Huh?
that is depends. Suppose we are changing a particular number by small value, how will it affect on the total result? If in this problem means if you change x by a small amount, how f of x will be affected? That is.
Yeah. So in that context, what is a well-conditioned and ill-conditioned system?
Suppose if the variation of suppose if, on x doesn't affect f of x, then if f of x is not blowing up or something, then it's a well-defined problem. But here, if small variation on x is creating large variations of x, f of x, and it will be defined.
Yes, correct.
Weak conditioned.
Yeah, that is the concept of conditioning numbers. Basically, it deals with like input and output. For suppose you have a system, you are giving it an input. Like practically thinking, you have a system, you give it an input, and it gives you an output. Correct. Now, if the input you are giving to your system, it has a small error, right? Then you have read that error propagates. And if you give that error to the system, it will give you some error in the output also. Correct. Now, for a small error in the input, if it gives a small error in the output as well, then it's a well behaved system. We say it's a good system, it is well conditioned. But suppose there are small fluctuations or small, like small error in input, but it gives very large error in like your output, then we say that this system is a bad system. It is not a well conditioned, it is an ill conditioned system. Correct. So in that context, if you have given any function f of x, you have to say that you have to find the condition number of it. For that, you have the formula
X into f dash of x.
f dash of x upon modulus of f of x divided by x.
X.
Now, this condition number tells you whether the system is well behaved or ill behaved. If the value of k is close to 0, then it's a well behaved or well conditioned system. If it's close to infinity, or the more it goes away from 0 and towards infinity, it is an ill conditioned system. Correct.
Yeah.
So here you have to do nothing, you have to find this. Now what is f dash x? It
It
is
is x,
e to the
e
power
power x
x.
by x into 1 plus x by x.
Yeah. It will be e to the power x upon x into x minus 1, it will be x square. Then f of x by x is e to the power x divided by x square. Something like this you will get. Here you can cancel out these two. Correct.
Yeah.
And you will get mod of, basically it is mod here, no? Modulus. So you will get e to the power x upon x square. These are positive, that's why I took them out of modulus. And they can be simply cancelled. Now x minus 1. So what will be the condition number now? For the value x is equal
If
to
x equal to 1, then
1.
it will be.
Yeah. For the value of 1, this condition number will turn out to be 0.
Yeah.
And that is, for this, it will be the well conditioned system for the value of x. Fine till here? Understood this? It was a
Yeah.
simple question. Should have
Yes,
been
madam, in this case, if you put x as 1, no,
Uh-huh.
then the condition it will be suppose if in the equation e power x by 0, if x equal to 0, then what will happen? It will be going to infinity, right?
Yeah. So e to the
Then
power, like, yeah, for this thing, if you are putting x as 0, then in that case it will be an ill-conditioned system for x equal to 0. So
yes.
for x equal to 1 or the
It is an
values which are
condition
near to
system.
1, it will be a well-conditioned system.
So if condition number, if you put x is 0, then it will be minus 1, right? So from this, how we will identify it as a ill-conditioned point?
Okay, for this,
Because it won't be going near infinity, right?
now you're telling if you put x equal to 0 here.
So, yeah, condition number will be 1 only.
Okay, wait a second.
But from the function, it's evident it is a ill-conditioned state.
Understood your point. Hmm, for But see, if you look at the function, you cannot put x equal to 0 because in that case the function will not be defined. Na?
Yes,
You
yes,
have
that
to
way we
first,
can.
while taking the differentiation, you have to say x is not equal to 0. Whenever we take
Okay,
differentiation and we define functions, we proceed with
yeah.
this thing that here is a
Okay,
denominator in x, x is not equal to 0.
okay, okay.
So for this case,
Okay,
it will not be equal to 0 and the condition
okay,
number will turn out to be 1.
okay.
So for the next question, okay. Next question is also a similar question. Uh, no, it's not similar. It's basically different. A good numerical procedure to avoid the cancellation error for evaluation of the function f of x is equal to tan x minus sin x whole divided by x minus under root of 1 plus x square, where x belongs to R is. So the question is that for given a function f of x is equal to tan x minus sin x upon x minus under root of 1 plus x square, you have to find the, like, you have to change it into a function where the cancellation error will be less. Now you know now you know how to avoid the cancellation error. First tell me what a cancellation error is. Anyone? Did you, like, study anything like this during the week?
Yes, yes, it's just there.
Yeah. So what? Tell me what a cancellation error is. See, uh, did I write the complete question? Yeah. And wait a second. Sorry, I forgot to mention where x belongs to R and x is near to 0. This is important. Okay. Is near x equal to 0 is. Basically, you know that in the computations, the errors propagate, right?
Yes, yes.
If there is an error in a function, then you perform certain arithmetic operations on it, say addition with another number which has an error. Then the error, like, contribute, the errors add or subtract, that you have done during the week, right? What happens
Yeah.
if there is multiplication of two numbers which have errors, how the error changes, like does it increase, does it decrease, in that sense. Now, in the particular case of addition and subtraction, you must have read, I assume, that when the like both values are close to each other. If there are two functions and their values are close to each other and they are of opposite sign, right? In that case, what happens? The error propagates, the error increases. Correct? In that case, we will not go into the proof and everything. I hope you might have read that. The instructor would have taught that how it propagates. Basically, what happens? The error increases. The error tends to infinity. So to avoid that problem, what we do, we try to eliminate the different signs in the functions. We try to bring it to positive signs. Like there is a minus sign here associated with sine, and you know that if when x is near to 0, what is the value of tan x? Tan x
Zero.
tends to what? 0.
Zero. Zero.
And sin x also
It's just zero.
tends to 0. You will not say that it is equal to 0, it tends to 0. So both these values are becoming close to each other. Similarly, in the denominator, you can see when x tends to 0, well, leave the denominator part. First, we can focus on numerators only. That tan x also tends to 0, sin x also tends to 0. So both the values are close and they are of opposite sign. So the error will propagate. That is the question. Like what the question is asking is that you have to change this function in such a way that these minus signs are somehow eliminated. Somehow you do some functions on it and it converts to a function where there are no negative signs, where the functions are not of opposite sign but of same sign. So give it a try before we discuss it. Anyone got the answer? Anyone who calculated the answer? So how will you approach it? Anyone tell me? I just want to see your thought process, how you're doing it. Gifty Kavita or
We
on.
can express this trigonometry functions as sum of other like
Yeah, like how will you do it? Any idea that is coming to your mind? Like, what are you trying? You tell
You
me.
can rewrite tan x and all as a function of.
Yeah. So you
If
can
So that we
you
simply.
can.
expand it, also get the negative terms.
Uh-huh.
If we expand tan and sin as x minus x cube by 3 factorial and tan as x plus x cube by 3 minus 2x power 5 by 15. In this way, also we get negative terms.
So it's not necessary you do that way.
Okay, so
Okay, let me give you a hint. You
another
can.
another way is
Uh-huh.
I don't know, is it right? Madam, first we multiply and divide by x
Sorry,
plus
there is a
root of
lot
1
of
plus x
noise coming
square.
from your side. I'm not able to hear you properly.
First multiply and divide by x plus root of 1 plus x square.
Uh-huh. Yeah.
And then in the numerator, I try the changes. Tan can be written as tan by cos, sorry, sin by cos minus
Yeah.
sin.
Uh-huh.
Then I just take it out sin. Then it is 1 minus cos x by cos.
Yeah.
That is
That is how you do
sin,
it.
sin squared x by 2 divided by cos. Then all the terms are in somewhat positive terms.
Yeah.
I
That is how you
try.
do it. See, you can write f of x as tan can be simply written as sin x by cos x. Correct. And
Yes, ma'am.
here this is x upon 1, sorry, x minus 1 plus x square.
X squared.
Sine you can simply take out as common. Then it will be 1 minus cos x upon cos x, correct? 1 minus
Yes, ma'am.
cos x. That cos x I will write here. Now this term, there is x minus under root of 1 plus x square. So multiply and divide both by x minus under root of,
Plus
sorry, plus
x plus.
x square upon x plus under root of 1 plus x square. So this will be a square minus b square. And if you evaluate that, a square minus b square will be something like this. This x square will cancel. Oh, sorry, it will be minus. This will cancel this, and this minus sign we can take out, right? And
Yes, ma'am.
in numerator, uh, in numerator, we will get something like x plus under root of 1 plus x square. Correct? Now there is this problem 1 minus cos x. Again, we will multiply and divide with 1 plus cos x. Right? So it will be sine minus of sine x upon cos x into x plus under root of 1 plus x square. Now multiplying and dividing with 1 plus cos x will give 1 plus cos x in the denominator, and in numerator it will be a square minus b square. That will be 1 minus cos square, right?
Sine
Understood?
square. Yeah.
Now 1 minus cos square x is what? Sine
Sine
square x.
square.
So it will be sine of sine cube
Thank
x
you.
into
X.
x plus under root of 1 plus x square upon cos x into 1 plus cos x. Now all the terms, like all the functions are like of the same sign, like there is positive only, there is no subtraction, there is addition only. So like this is the final form of it. Understood?
Yeah.
This can be used as the functions form for evaluation to reduce the cancellation errors. Has everyone understood? Others also?
Yes.
Copy it as well. Take a minute to copy it, then we will move further. So, Should we move ahead?
Okay.
Yes, ma'am.
Okay. So now this question I want you guys to do it quickly because it is basically the same question we did earlier. The question is that for what value of x the function f of x equal to x plus 1 to the power alpha, where alpha is not equal to 0 belonging to R, is ill conditioned. The previous question you had to find when it is going to be well conditioned. In this question you have to find when this function is going to be ill conditioned. So quickly do it, find the condition number, then only you can comment on what the value of x should be. Tell me the expression you are getting for this condition number. Anyone got the expression for k?
K is alpha x by x plus 1.
Yeah, that is correct. So basically f dash x is what? It will be alpha into x plus 1 to the power alpha minus 1, right? Simple
Yeah.
differentiation.
Yes.
And k is f dash x modulus of f dash x upon modulus of f
F
of
of x
x
by x.
by x. Someone is joining. So now here we can write it as alpha of 1 plus x to the power alpha minus 1 whole divided by 1 plus x to the power alpha upon x.
X.
Here simply you can see this is 1 plus x to the power alpha minus 1, and here it is 1 plus x to the power alpha. It will be subtracted from this, right? It will be alpha into 1 plus x to the power minus 1,
By,
and this
by,
x
it will go
will
up.
be come up and it will be right here, right? Now you can write this as modulus of alpha into modulus of x upon modulus of 1 plus x. So what is the value for which this system will be ill conditioned? For
X
this
equal to
system,
minus 1.
yeah, for this system to be ill conditioned, we know that k should approach
Infinity.
infinity. For that, the x plus 1 should be equal to
0.
0, correct? And
Yeah.
that implies x should be equal to minus 1, right? Understood, everyone?
Yes.
How many of you have solved the week assignment and like every question of it?
Some questions where I could get, ma'am. 1 or 2 questions are still there.
Okay, okay. And what about others?
Myself tried but not completed fully.
Okay. So the questions would be similar, or like they are different, or
Similar only that round off and all I had some doubts.
okay.
Round off, how to round and all.
And there are, I think, simple rules only for round off.
Yes.
So there won't be any tricky questions. I think after this
And
session.
some actually there are some questions if you do in calculator,
Mm-hmm.
for example, x plus 5 the whole power 5.
Uh-huh. Uh-huh.
So x will be some value, then there will be another formula to reduce the errors. No, but then when I evaluate through calculator, I'm getting the same value. That's it.
Okay.
I
Sometimes you
think I
can
should
get
do
same
in
value
steps
also,
and
because I tried one question. I was getting same value for both x and x star. But in case of x, you take the whole value. In x star, you will
yeah.
round it off. After that,
Okay,
taking the value.
then that may be the reason.
Yeah. So now, let's move on to another question. Right? Have you copied this?
Yeah.
Others. Okay. Let's do. Okay. So consider the 3-digit decimal system with rounding. Let y star denote the value f of 2.72 when it is evaluated by using the formula f of x equal to x
This is a question I am telling, ma'am.
of assignment.
Yeah. Similar question is there. Not same, similar question is there.
Okay, let's discuss this. After that, I hope your doubt will be cleared. X minus 4 into x plus 6 into x uh, minus 4 for y equal to f of x equal to x minus 1 to the power 4. Then the number of significant digits by which y star is y star approximates the actual value y is. So please give me a moment. Meanwhile, you can copy the question and like give it a thought. Okay, so everyone noted this question?
Yes, yes. Here, to compute
Ah,
by the formula, then every step we have to do.
sorry, what?
To compute by the formula, then we have to do it in each steps.
You're actually not clear to me.
Actually, this when you compute by f of x, no?
Uh-huh.
Like that, equal to x minus 4 into x.
Uh-huh.
That we should do by step like that.
Yeah, I'll explain.
Okay.
See, now firstly, we have here that we have to take the three-digit decimal system, right?
Yeah.
After decimal, there will be 3 points. So you can see that even the input is also given in that only 2.72, right? So for calculating the actual value, we are going to use this function. Let me use a different pen. This is for actual value. And this one, which is the nested form, this we use for approximate value. Correct?
Yes, yes.
So what we do here, now when you input f of 2.75 in what? This function x minus 1 to the power 4, what are you getting?
8.75 to 13046.
It is 2.72.
Oh, sorry.
8.75
Wait a second.
to
It will be 2.72, correct? So to the power 4, right?
yeah,
So what are you getting?
8.75 to 13056.
Is it 8.27? Wait a second. I think I made some mistake. Wait a second. 2.72 minus 1 to the power 4. Yeah. It's 8.75
To
to
1 5
13056.
6.
So this is what? It is y.
Y. Yeah.
Correct?
Yeah.
Now for calculating y star, what you do? You put 2.72 in which function? This one, right?
Yeah.
Put it quickly and tell me what you are getting.
The same.
Wait a second. You're getting the same?
Yes.
Wait a second.
Yes, using calculator it is coming the same, ma'am. That's why I told earlier. Whether we have to do it hand calculation like x minus 4, then we have to round it off, then multiply by x. Again, we have to round off. Like that, we have to do.
No, we can do it this way also.
This you do same value we are getting.
You try it that way and tell me what you're getting. No, this is coming out to be same. So that is not any problem. You can round it off simply. Because I cross checked it twice. And even if you do it by hand calculation, you're not getting any more significant digits. So,
But actually, in this assignment, no, there is some value given.
uh-huh. Like the answer.
Yeah.
Yeah, this is the previous year assignment. We will solve it. And
Yeah.
I was getting the correct answer when I did it on my own end.
If in this new Y star,
Uh-huh.
we round off up to 3 decimal places.
Uh-huh. Yeah, we will round off. I am doing that in next step, like here only. So here,
What to
what is the
do?
third digit? This is 5, right? This is t equal to 4, no? Yeah, sorry, t equal to 3. So this 5 you will have to round off, and you can see that after 5 there is 2. So it will simply be 8.75, correct?
Yes.
Now, uh, what we have to do? Then we have to find the relative value, right?
Yeah.
So what you are getting the relative value? Tell me quickly. It will be something like 8.75213056 minus 8.75 upon 8.75213056.
2.43, 10 power minus 4.
This expression is coming out to be 2.43 only, right?
Yeah. Into 10 power minus 4.
Okay. Now, then the number of significant digits by which y approximates actual value. Yeah. This is what
3.
we are getting.
Yeah.
So you know
It will be 3.
for finding the approximate digit, since this number is less than 5, right? So what you do, the significant digit, say that is k, then k plus 1 is equal to 4. This, and k will be what? 3. So this function approximates the value of this function up to 3 significant digits.
Ma'am, you told up to this 2.43 is less than 5, then
Uh-huh.
we are putting k plus 1 is 4. If it's more than that, how we will do?
Then you have to simply take that as k.
Okay, okay.
Yeah.
Um, how do you put k plus 1 equal to 4?
See, this
That
is just
step
an
I not
expression.
understand.
See, for checking, I think you would have read this in lectures, that when you find the relative value, right? This thing, if it can be expressed in the form of, say, alpha plus 10 to the power minus beta. Here alpha, if it is equal to 5, then this beta, it will be equal to k plus 1. And here you see that it approximates the value of the function correctly up to k significant digits. So here k plus 1 was 4, then we say that k is equal to 3. So we say that this function, the given nested function, it approximates the value of the actual function, which was x minus 1 to the power 4, up to 3 digits, like 3 significant digits. Understood now?
Now, if it's 8 means, how we will do?
If
Alpha
it's,
is 8 means, then beta equal to k,
8.
that they will take.
Yeah, if alpha is equal to, if f alpha is like
Beta is k will take. Huh?
yeah, then we will simply take it as k.
Okay. If more than 5, we'll take beta as k, like that.
Yeah, if
Yeah.
more than 5, if this is less than 5, then k plus beta is equal to k plus 1. If this is more than 5, then beta is equal to k.
Okay.
I'll check it once again, but yeah, it is this only. So you note this down. So similarly, attempt the assignment question,
Okay.
then tell me what you are getting. Like if you're getting the error again, then we can discuss it in next session.
Okay.
So copy it. Should we move ahead?
Okay.
Okay, so let me. If x1 is equal to 2.21083 and x2 is equal to 1.17975 are two floating numbers with relative errors epsilon 1 and epsilon 2 satisfying epsilon I is less or equal to 10 to the power minus 5 for I equal to 1 comma 2, then FL of x1 x2 minus x1 x2 is approximately equal to what? Like you have to find this value. Give this question a try. We have again two functions, two numbers are given, x1 and x2, and their relative errors are e1 and e2. Now, if we multiply those numbers in the floating form and subtract from x1 x2 again, then uh, what is the value of this expression? That is what you have to find. So how will you approach this question? Simply expand this thing first, like we did in previous questions also. And tell me what you are getting the like simplified version of this expression. Give it a try and then we will discuss it. So anyone got the expression for this thing? A simplified expression in terms of epsilon? Do you need more time or should I discuss? Okay, you can take 5 more minutes, like 2, 3 more minutes, then we can discuss. And in meanwhile, if anyone gets the simplified expression for this, because this is nothing, I think you must have read like how errors propagate in multiplication. So simplifying this is, matlab, you should be able to simplify this expression. Anyone? Kavita Gifty?
Actually, the x1 x2 into epsilon x1 plus epsilon x2, the expression after simplification, float of x1 x2 minus x1 x2 is approximately equal to x1 x2 into some x1 x2 into epsilon x1 plus epsilon x2. After that, have to do.
Okay, you're doing it somewhat correct, but I think you have made a mistake above. So see,
Okay.
you know that float of x1 x2 you can simply write it as what?
Root of x1
x1
x2
into
into
1 plus epsilon 1 into what? x2 into 1
1.
plus epsilon 2, right?
Yeah.
You can write it that
Yes.
way. And x1
Um,
x2 is simply the number. Then here you can see x1 plus x1 epsilon 1. Wait a second. No.
no,
Let
no.
me do it this way.
X1 into
Yeah, yeah.
x2.
We can multiply it simply. x1 x2,
Uh,
and here
1
it will
plus
be
epsilon.
1
to
plus
1
epsilon 1
plus
plus
epsilon
epsilon
1
2
epsilon
into
2
epsilon 1 epsilon
higher
2, right?
power.
That will
Higher
cancel
power
with it.
is like
Now higher power we will neglect,
Cancel.
right? It will be x1
Okay.
x2
Sorry.
into 1 plus
Those two
epsilon
get
1 plus
cancelled.
epsilon 2 minus x1 x2, correct? Now epsilon 1 plus epsilon 2, simply we can write it as epsilon, right? The error which propagates.
Yes.
So x1 x2 here we can take common, or maybe we'll do it in next step. So we can write 1 plus epsilon minus x1 x2. Understood till here?
Yeah.
Now
Yes, yes,
x1
ma'am.
x2, taking it as common, 1 plus epsilon minus 1, it will be something like that. This and this will be cancelled. It will be x1 x2 into epsilon. I think you might be making some mistake here. That's why you are getting a different expression.
Same
Now,
only I get. Ma'am. I just said x1 x2 into, in place of epsilon I said epsilon 1 plus epsilon 2.
okay,
That's
okay.
all.
You said epsilon 1 plus epsilon 2. That is correct.
Uh,
Okay, okay. Actually, your voice is breaking, or maybe the problem is on my end. I'm not able to like
okay,
properly hear
okay.
your voice of anyone. So now this is the final expression for this, and See, in the question it is given that for I equal to 1 and 2, like it is coming the epsilon, the error is will be of order 10 to the power minus 5.
Minus 5.
So epsilon is of the order 10 to the power minus 5, right?
Yeah.
If even if epsilon 1 plus epsilon 2, it will be of the order 10 to the power minus 5, right? Now what you have to find, uh yeah, now in this case you will simply multiply. You have to find the value of this expression, no? Then simply put the value of x1, which is what, 2.21083, and put value of x2, which is what,
1.17.
1.17975. Multiply it with 10 to the power minus 5. Tell me what is the multiplication you are getting for these two numbers?
2.6069.
2.6069.
Yeah.
Okay, I think
001.
you have rounded or something. It's coming
No,
out to
no.
be 2.60 because I have calculated it. It's something like this. You maybe check it once more.
This one is correct, ma'am.
Yeah,
2.608226.
8226 you are getting.
Yes, yes.
Wait a second.
And
2.60.
rounding, I am not.
23. 10 power minus. So yeah.
It is coming out to be a longer number,
Hmm.
2.60822669, right?
Yes,
Yes,
You
yes.
ma'am.
can
Yeah.
take it anything. I took this one because I think this was given in the question.
Okay.
So
Okay.
yeah, this is given in the answer. Yeah, let me check. There are four options, so this one is correct. 2.60823. Basically, they have given only five numbers after decimal. So this one is the most correct. Everyone was, others were like 3, 2, 4. So this is the final answer. So everyone understood this question?
Yes, yes.
Yes, ma'am.
What about others? So I think this much is sufficient for today. Like I guess I have covered all the topics, or if there is
Yes, yes,
anything
yes, yes.
remaining.
Yeah, one method, one problem has come in all the topics.
No, yeah.
Yeah.
So like this was us like this week the content was not that heavy, so the questions were also like simpler ones. That's why we completed in less time only. So I think we can end the session right now, or if you have
Yeah.
any other doubt or anything, you can suggest me
Then
right now.
that regarding that exam question, any information you have?
Yeah, I was busy also, but as I asked my seniors who were doing PMRF TA duty, they said that mostly the questions are asked like in this pattern only, the way they are
Okay.
in your assignment and in the previous
Yeah.
year assignment. Because see, this was the previous year assignment. So
Yeah.
you might have found that there is at least 70% similarity between your assignment and this, right?
Yeah.
If not
Yes.
70, at least 50%.
Yeah.
So you can expect that the question